8.5. Right towards the end, they do a solving equations section. It's very brief, and it's not really connected too much to what we did prior in the section. But there's something interesting in this example that they give that I'd like for you to see. So solving equations. Let's look at this. Sine theta plus cosine theta equals 0. Y'all doing okay, by the way? You all right? Ready for the weekend?
Yeah, I feel like more people were eager to get out. So it's a short class.
Yeah, it's kind of thinning out a little bit here.
Was that midterm verification?
Maybe. Yeah. All right, so how about this? Any ideas? Solve this equation for theta. So we're asking, what angle do I plug in here and angle do I plug in here to make this 0? Zero. Okay, so 0 here, is that what you're saying? And pi over 2 here, but they have to be the same angle, right? Because it's theta and theta, so it has to be the same angle. So let's just try and do a little bit of algebra, all right? Let's do some algebra. Let's just move some things around. Sine theta equals negative cosine theta, right? That's me just subtracting cosine theta from both sides. That's saying where's the y-coordinate on the unit circle equal to the opposite of the x-coordinate, right? They're off by a sign?
3 pi over 4.
3 pi over 4?
Yeah.
Is that the only one?
Also 7 pi over 4.
7 pi over 4?
But cost ain't negative.
But what?
The x-coordinate ain't negative.
It's okay, they just have to be opposite in signs. So where are the x and y coordinates pretty close to each other? It's happening here, right? Here, here, and here. Because here it's root 2 over 2, root 2 over 2, right? And then this one, they're the same, but they're off by a sign. Here they're the same, aren't they? Both negative. And here they're the same, but off by a sign. All this is saying is, this is the y-coordinate, right? This is the x-coordinate, but you want it to be off by a sign. So it should happen here and here, right? 3 pi over 4 and 7 pi over 4. Yes? Now that's fine. But if I were to do one more thing here, could I divide both sides by cosine theta? At this point. What sine over cosine? Tangent. Tangent theta equals -1. And that's the exact same question. This is saying, where's the ratio of your x and y coordinates, or y divided by x? Where is that ratio -1? So where are they the same but off by a sign? Here and here. Yes? Now that's not the problem I wanted to show you. That's just I wanted you to think about that problem and how we would solve that. Let's compare that to this one. Just going to be a very slight modification, but it's going to create a major problem for us. There's the next one. Oh, I should put the answer here, sorry. Theta is, do you want the general solution, or do you just want just the solutions between 0 and 2 pi? I didn't specify.
General solution.
You want general? Okay, so the general, I could just use this one, right? Here are my answers, here and here.
Yeah.
So I could just say 3 pi over 4 plus n pi, or pi times n pi. And then I could get common denominator. And that's because this point right here is directly across, right? Okay. Questions? Sure?
What? No.
I thought y'all were discussing now. We're good? What about this? What's the difference? How's it going, Zach? Yeah. Good. Okay. What's going on with this? See the difference? Yeah. Just that one, right? Which seems like it wouldn't make much of a difference. It's going to make a dramatic, huge difference. Because if I were to try and move the cosine over like I did last time, we're not saying that the y coordinate has to be the x coordinate but off by a sign, because there's a 1 over there now, right? So it's completely different. So I can't do that. So this is one of those problems that I show you, and I show you like a method, a technique, and then you're like, wow, okay, I didn't even realize I could do that. You've done this before, but it's not something that you would automatically think to do right now. I'm going to square both sides of the equation. Okay? Now, do you remember when you were in college algebra, when you square both sides of an equation, that you have to do something when you're done?
You have 2 answers, plus and minus.
Yes, well, that's when you take the square root. I'm saying when you take an equation and square it, that's legal. You can do that. Let me illustrate. If I have square root of x plus 1 equals x. Back in college algebra, we call that a radical equation. If we were to solve for x here, or try and solve for x, we would isolate the radical, and then we would square both sides. And then you go and work it out and you get an answer. You probably get 2 answers because it's quadratic once you square both sides. What do you have to do when you get that answer? Those answers? Let's do this. Let's do this one. Let's square both sides. If I square the left side, I get x. If I square the right side, I get x squared minus 2x plus 1, because you have to actually square it and FOIL it out, right? Now let's move everything over, make it a nice quadratic. Oh, that's going to suck. That doesn't factor. So I'd have to use a quadratic formula, right? So if I use a quadratic formula and I get 2 solutions here, are those the answers, guaranteed? No. I might have an extraneous solution. Anytime you square both sides of an equation, it's legal, but you must check your answers. Okay, is that what you meant by plug in or something? I don't know.
Yeah.
Either way, you have to check your answers. One might not work. Okay, one might not work. So the squaring effect can sometimes introduce solutions that don't work. Extraneous solutions is what they're called. So I am going to square both sides here, but I'm going to keep in mind that when I do this, I'm going to have to check my answers. And when I say check back into this right here. I'm going to have to take them and put them back in there and make sure they work. So when I square the left side, that means I have to FOIL it out. I have to do sine plus cosine times sine plus cosine. I'll go ahead and write that down. Sine theta plus cosine theta. And then sine theta plus cosine theta again. And of course, 1 squared on the right is just 1, so I'm not even thinking about that. All right, here we go. Sine times sine, sine squared. Cosine times sine is cosine times sine. And then we have another one of those in the middle. Did I just do it twice? I just did it twice, sorry. I didn't mean to do that. It was here to here, here to here, then here to here, here to here. It doesn't matter the order you do it, but we should get the same thing. Our middle 2 terms will be the same, right? They're the same terms. Then the last one is cosine squared. Theta equals 1. See anything? Cosine squared theta and sine squared theta? Those add up to be 1. So this and this together is 1. And then those middle 2 are the same. So I have 2 of them, don't I? So this is 2 cosine theta, sine theta, and then equals 1, right? Now subtract 1 from both sides. And if we subtract 1 from both sides, 2 cosine theta sine theta is now equal to 0. This is when you subtract one that's gone. Isn't that nice? Let's divide both sides by 2. Dividing both sides by 2, you get cosine theta times sine theta equals 0. Now, this is saying that when you multiply these two together, you get 0, so we can set each factor equal to 0. This is what we did when we factor quadratics, right? We get two pieces equals 0, we set each factor to 0. So I'm just going to set each one of those to 0. The other one, sine theta, is 0. Where is cosine 0? Pi over 2, 3 pi over 2. Oh, there's an infinite number of solutions, okay? But I'll just draw them here for now. I'll write down the answer in a second. Where is sine 0? Here and here, right? That's where sine is 0. So it appears that if I look at the answers together, how could I write the answers together? Like in one general solution. These two combined with those two would really be, right? You add pi over 2. Where do you want to start at? You want to start at 0? So the general solution for this would be theta equals 0 plus pi over 2n. Or theta is just any multiple of pi over 2. That would be your general solution. Any multiple of pi over 2. And then you could start using different values of n, right? Let's check and see if they work. Let's start at 0. Okay, if n is 0, let's see if this thing is true. What would the theta be if n is 0? What would theta be?
If n was 0, it would be 0, 1.
0, right? Is 0? And let's check that into the equation. What's sine of 0 plus cosine of 0? Sine of 0 plus cosine of 0. Oh, I meant. What's sine of 0?
1. Cosine of 0 is 0.
Sine of 0 is 0. What's cosine of 0? 1. So this is 1. That checks, right? So if I'm thinking about this, I know that this answer worked, right? That one worked. And that means if I go all the way around, it should work also. Okay, let's check this one up here. That will be if n is 1. We'll get that theta is pi over 2. And that means if we plug in pi over 2 into this, what's sine of pi over 2? 1. So sine of pi over 2 plus cosine of pi over 2. So this should be 1 plus cosine of pi over 2 is 0. So this is 1 that checks. So I know this one works. What about pi? So that means we're going to let n be 2. Theta is, if we plug in 2 for n here, we just get pi. And what is sine of pi plus cosine of pi? Sine of pi? Cosine of pi? -1. Is -1 equal to 1? No, this one did not work. That's an extraneous solution. So this guy kind of crept through because of the squaring. This one's no go, right? And then we should probably check this last one and see what happens. I don't think it's going to work. N equals 3. So theta would be 3 pi over 2. And then we have sine of 3 pi over 2 plus cosine of 3 pi over 2. So sine of 3 pi over 2 is -1. Cosine of 3 pi over 2 is 0. So this doesn't work. So both of these were bad. So that's bad. So that means we would have to adjust our solution set, right? This would no longer be okay. I would need to have this guy and all of the different equivalent angles, which means I'd have to go around by 2 pi to get back. And then I'd have this one and go around by 2 pi to get back to that one. So I'm going to have 2 sets of general solutions. They are going to be, theta is 0, right? This one is 0 plus 2 pi n. And how about the other one? Or theta is pi over 2 plus 2 pi n. Okay, the moral of the story there is that, yes, you can square both sides of a trigonometric equation, so long as you go back and check your answers. You could get rid of this 0 here and just write 2 pi n, because 0 plus 2 pi n is still 2 pi n. All right, we're going to move on. We are moving on to 8.6. Double and half angle formulas. So last class we did the sum and difference formulas, right? There were a lot of formulas from last class, right? And those all appear on the formula sheet that's on the back page of the book, or in the last page. You should have this. If you don't, does anyone not have that formula sheet? It's the one I gave you on the test. Okay, you should have that. All the formulas we did last class were the sum and difference formulas. Those are on the bottom left-hand corner of that sheet. What we're going to do now are what are called the double and the half angle formulas. So I don't think I'm going to spend time to show all of them, okay? Maybe just the first one. So we're going to start with the double angles. All right, sine of 2 theta is equal to 2 sine theta cosine theta. I actually did this one in class last time. I showed that to you. I proved that to you by writing down sine theta plus theta. That's what I did. I said, what's sine theta plus theta? And then we used the formula to come up with that. Okay, so you can refer to your notes for that one. So I'm not going to prove that one to you. And I also told you that this comes up a lot, right? I did say that this is one that you should try and burn into the memory bank. The next one, cosine of 2 theta is equal to cosine squared theta minus sine squared theta. This one's weird. This almost looks like the Pythagorean identity, doesn't it? Except that it's a minus. And it has to be the cosine squared minus the sine squared. You cannot switch the order. If you switch the order here, then that means it would have to be a negative out here. So you have to have the cosine before the sine. Now let's see if we can't prove that one. Let's see if we can do it. And this will be the only one that we prove. So we want to prove it using last class. I want to know what's cosine of theta plus theta. Because that's 2 theta, right? From last class, we learned that that means you have cosine theta, cosine theta. If it's a plus, now it's minus. Oh my gosh, is this not like just ridiculous? I mean, that's it, right? That wasn't too bad, was it? Y'all know what formula I'm using, right? It was cosine of alpha plus beta was cosine alpha, cosine beta, minus sine alpha, sine beta. Using that formula with theta for both alpha and beta. All right. Now, that's not the only formula that you're going to see in your book for cosine 2 theta. Your book or your formula sheet is going to have two other equations here. So they'll say it's equal to that, or you could say, let's see the order they go in here, 1 minus 2 sine squared theta. They said that, you can use that formula also. So like you can use this, or you can use this. How do you think we can go from this formula to this formula? Look at this, well, look at this right here, cosine squared theta minus sine squared theta. How do you think I could go from this formula down to this one? What does this one not have in it that this one does?
Cosine.
Cosine. So how could you get rid of a cosine in here? 1 minus sine squared, right? Use the Pythagorean identity. If we replace this right here with 1 minus sine squared, theta, and then we already have a minus sine squared theta, then if we put these two together, we have minus 2 sine squared theta. And that's that formula right there, right? So you're free to use, whenever you have cosine of 2 theta, you can switch it to this, or you can switch it to this. It's your choice. And usually the problem itself will tell you which way you want to go with that. Like, do you want to have both cosines and sines mixed in? Use this one. If you just want sines, use this one. And then the last one is the opposite, basically, of this. Cosine squared theta minus 1. How do you think we get this one?
We sort sine to cosine.
Yeah, so we go back up here, and we replace sine squared with 1 minus cosine squared. So cosine squared theta minus 1 minus cosine squared theta. Like that. And then now distribute through, right? Negative 1 plus cosine squared, so 2 cosine squared thetas minus 1. All right, these are your double angle formulas. There's also one for tangent of 2 theta, but not used as often. 2 tangent theta. So much, I don't use, I can't even remember the last time I used this formula. But you should know that it's there, all right? So this one, definitely put it in the memory banks. This one, know that there are 3 equivalent versions of it. Those you should know. This one, just know the formula is there. Okay. So let's do a problem. Now that we have these formulas, let's do something with them. Example. If sine of theta is equal to negative 4/5 and theta is between, sorry, my theta is in the wrong place there. Theta is between pi over 2 and 3 pi over 2. Find sine 2 theta and find cosine of 2 theta. All right. So notice that here you're given information about sine of theta, right? But we would like to know something about, not theta, twice theta. So if I were to try and visualize this, what I have is some angle theta. Now where does this angle live? Somewhere between here and here, right? Can you actually narrow it down even more? It's in the 3rd quadrant because sine is negative, sine's the y-coordinate. So I know that I have an angle, theta, that is somewhere over here, all right? That's theta. And I know that sine of that angle is this value, But we're interested in figuring out what's sine of 2 theta and cosine of 2 theta. So twice theta would mean doubling this angle, right? Whatever that is, 2 theta is a totally different angle. I'm going to have a totally different y and x coordinate, right? So these ratios are going to be different. We should be able to figure out what sine of 2 theta and cosine of 2 theta are by using the double angle formulas. Because in the double angle formulas, they just have sine theta and cosine theta in them, right? Which of these two would be easier to do first, and why?
Cosine?
Cosine, why?
Because it says like 1 minus 2 sine squared theta. We have like the sine value, we don't have cosine yet.
Okay, good. So in the cosine formulas, there was 3 of them, right? One of them had both cosine and sine in it. One of them had just sine in it, and the other one had just cosine in it, right? I know sine of theta. So I can find this one right now by using the formula 1 minus, what is it?
Sine squared.
It's 2 sine squared
2 sine squared theta.
theta, right? I can do this right away because I know what sine theta is. So the way I'd write this is 1 minus 2. Now, keep in mind what that squared means. Do not lose sight of the fact that the squared on the sine theta means you're squaring sine of theta, right? What is sine of theta? Negative 4 over 5. Squared. So let's just do order of operations here. We have 1 minus 2, square the top and bottom of that, 16/25. And then multiply by 2. So you get 1 take away 32/25. It's negative 7/25. Just getting a common denominator, right? 25 over 25 here, subtract negative 7 over 25. There you go. Do we know what quadrant 2 theta is in? Do we know where 2 theta is? I just drew it here just to draw it. We knew that theta was here, right? Somewhere in the 3rd quadrant. We could tell from this, right? But do we know where 2 theta would be?
Second.
Second? So how about we look at it this way for a second? Here's theta, right? Theta's between here and here. If I multiply this by 2, this by 2, this by 2, I would get this, wouldn't I? Yeah? That means that 2 theta has to be between what? Pi and, right, this is pi, right? 2 pi, 3 pi, which means it could be anywhere, right? Now, I do know a little bit about it because cosine of 2 theta is negative, which means that it must be over here somewhere. Understand? Now, I will be able to nail down which quadrant it's in. Once I start looking at sine 2 theta, I should be able to figure out where it is. All right? Okay, let's move on. We have cosine 2 theta. Let's find sine 2 theta. What's the formula I'm going to use for sine 2 theta?
2 sine theta cos.
Yeah, I only have one option. 2 sine theta, cosine theta. And the problem with this formula is that to do it, you need sine theta, which we have, right? But you also need cosine theta, which we don't have, which we need to go find. So how are we going to figure out what cosine theta is?
Reference triangle.
Triangle, right? We're going to do something. We're going to use this to figure out what cosine theta is. So if I say that sine theta is negative 4 over 5, I can draw a reference here. I know what quadrant I'm in, right? I know I'm in quadrant 3 because this told me I was between pi over 2 and 3 pi over 2. y-coordinate has to be negative. Sine is the y-coordinate. So when I draw my triangle, it's going to look something like this. And sine is the opposite over hypotenuse. So -4 here and 5 here. And we can solve for that. Pythagorean would give us a 3, but because it's to the left, it would be -3. Are you all comfortable with that now, doing that sort of thing? All right, so what would cosine theta be? Okay, so I'm going to erase this. I'm doing this part right here. So from here I say, okay, well, cosine theta, based upon that, is -3/5. And that means that this formula now becomes 2 times sine theta, which is -4/5, times cosine theta, which was -3/5, which is 20, what is that? 24 over 5 times 5, right? So 25. 24/25. It's got to be less than 1, right? Because it's a trig function. It's got to be less than 1. 24/25. What quadrant is 2 theta in?
Third, second.
We know that the x-coordinate sorry, I erased it. Oops. What was cosine of 2 theta again? We just found that out. -7/25. Okay. So we know that the x-coordinate of 2 theta is negative, and we know that the y-coordinate of 2 theta is positive. So that means we must be up in the second quadrant, right? So twice theta is in the second quadrant. All right, what did y'all think of that? All right? Yeah, a lot to remember. And I think I was saying last class, this is definitely one of those classes where everything's building on itself. So like this little part of this little triangle used to be like a problem on the test, right? Now it's just like a sub-part of a bigger problem. Let's try another one. What if we have tangent theta is 4/3 and theta is between pi and 3 pi over 2. I want us for this to find sine 2 theta and cosine 2 theta. And then I want to go one additional step. I want us to do tangent of 2 theta. Notice that I left the parentheses off here. I just did that because sometimes the parentheses are there, sometimes they're there, sometimes they're not. As long as there's no confusion of what the argument is. The argument of this trig function is 2 theta. We are not saying this. We're not saying sine of 2 times theta. Right? We're not saying plug 2 into the sine function, then multiply it times theta. We're saying plug 2 theta into the trig function. So if you want to be safe, put parentheses around the argument just so there's no confusion. All right. To do this, I'm going to have to know what sine and cosine are, right? Yeah. Sine of theta and cosine of theta are. To do this, I can know both cosine and sine, or I can know just sine or just cosine. But I know tangent. I don't know just sine or just cosine yet. I'm going to get them. And then tangent 2 theta, well, we'll deal with that when we get to it, okay? So why don't we do a triangle now and get our other trig values? Now, fortunately for us, they already locked us into the, what, third quadrant here? We're already locked in, so that's good. And we have a ratio here. Tangent is always going to be your y over x, right? So this side's going to be -4, and this side's going to be -3. So good. Y'all are starting to pick up the idea that you need to know what quadrant you're in so you can put the appropriate signs on these. Okay? And then you have to solve for this side. 5. Pythagorean. And remember, the hypotenuse is always positive, so you don't have to worry about that part. And let's just list it out then. Sine theta would be -4 over 5. Cosine theta would be -3 over 5. And tangent theta we already know, so that should be sufficient. So sine 2 theta is 2 sine theta cosine theta, which is 2 times sine of theta, -4/5, times cosine theta, which is -3/5. And this turns out to be, is that 24/25 again? Okay. Which one would you like to use for the part B? Doesn't matter which one we use, really. Let's use the first one because we haven't used that one. Let's do the cosine squared theta minus sine squared theta. That's the formula, right? So we're going to take the cosine one, which is -3/5, right? And we're going to square it. And we're going to subtract the -4/5, and we're going to square that. Is everyone clear on where all those come from? Yes?
It'll be -7 over 25.
So 9/25 minus 16/25, -7/25. Questions? All right, what about tangent theta?
Sine 2 theta over cos 2 theta.
Yeah, we could use the formula that I actually gave you, right? I gave you a little formula there, and I said this is something I don't memorize and, just know it's there. We could use that, but we could also just use the definition of tangent, which is sine over cosine. So I could say this is sine 2 theta over cosine 2 theta. Just make sure that it's 2 theta that you're plugging in here. Do we know sine of 2 theta? We just found it. It was 24 over 25. And then do we know cosine 2 theta? Yes. -7 over 25. And then these flip, right? They flip and reciprocate, and the 25s cancel, and you should just get -24 over 7. All right. What quadrant is 2 theta in? Your sine is positive,
Second.
and your cosine is negative, which means that your y-coordinate is positive, and your x-coordinate is negative. So you're in 2. Theta was in the third quadrant, but 2 theta is in the second.
So is this like any theta that lands at the third goes back to the second? Like the previous one?
Not necessarily. I think you could say that. See, this is what it would mean to land in the third, right? So if I double this angle, 2 pi less than 2 theta less than 3 theta. The best I can tell you is that doubling the angle would land between 2 pi and 3 pi. So it is possible for that angle to land in the first quadrant. I mean, you could just give yourself some examples, like take degrees because they're a little easier. If you take, let's say, 182 degrees and you double it, you're going to be at 364. So 364 is all the way around, plus 4 degrees, you'll be in the first quadrant. But if you get past 45 here, it'll pop you into the second one. All right, let's talk about the half angle formulas. Now the half angle formulas, I like the what they call them. You know, the half angle. You'll see why in a second, why they call them the half angle formulas. But I am going to also add something to these that some other books call them something else, and I think in calculus 2 it makes a little more sense to call them what I'm about to put up here. These are also known as the power reducing formulas. All right. Now let's see where they come from. Okay. I'm going to write the formula up here first. There's 3 of them, but I'm going to write the first one up here. Sine squared theta equals 1 minus cosine 2 theta over 2. Okay. Sorry, this is, let me say this. This is not the formula yet. Not formula yet. Okay. Okay, I'm going to get us to the half angle, all right? But I want to start out with this first. I want to show you where that comes from first, all right? And then I'm going to use that to get to the half angle formula. So on this right here, what we could do is just solve that for cosine 2 theta, okay? I want to try and make you believe that this is true. So what would happen if I multiply both sides by 2 here? What would I get? 2 sine squared theta equals 1 minus cosine theta, 2 theta. Okay, now what I'd like for you to do is take the cosine 2 theta, move it to the left, take the 2 sine squared theta, move it to the right. And what would it say? Cosine 2 theta equals 1 minus 2 sine squared theta. And do you recognize that? That's the double angle formula for cosine. That's one of the 3, isn't it? So what I'm getting at is, if I started with this, do you agree that I could move things around and turn it into this? Yeah? Okay, so we all believe this right now? We all believe this? This right here is what I refer to and other books refer to as the power reducing formula. Here's what it does. This right here, I'm going to box it. And again, this is not the half angle. The half angle looks a little bit different than this. All we're going to do is take a square root, and then we're at the half angle, all right? But if I look at this formula as it sits, it says that if you have sine being squared, right? And you know, if you don't like the squared being there, and you want to get rid of the squared, you can do that. You can get rid of the squared by turning it into this expression. Now what happens is your power goes away, right? You no longer have anything squared over here, do you? And you introduce a new trig function. Instead of sine, you have cosine, yeah? What you give up in this is you're allowed to pull the power down and get rid of the power, but you now double the angle. So see how we had theta here, and now it's 2 theta here? That's the give and the take. I have a squared expression. I can make it not squared expression. but I've got to double the angle into this formula. This is going to become very useful in Calculus 2, and we're actually going to do something in here today that you have to be able to do in Cal 2 to do a certain type of problem. Do y'all remember the difference quotient in college algebra? Yeah. F of x plus h minus f of x all over h. And they like beat you over the head with that for a while? Yep. Did they tell you because you need to do that in calculus? You have to be able to do that? Yeah, same sort of thing. I'm going to show you something here that you're going to need to be able to do in calculus. But this is the thing that we use right here. Now there's another version of this. If you have cosine squared. And it goes like this. Cosine squared theta equals 1 plus cosine 2 theta over 2. So what is the difference between those two formulas?
One's negative, well, sine and cosine are different, but it changes the cosine from negative to positive.
Yeah, so if you want to go from sine squared and no longer have squareds, you're going to plug it into this, right? And it's almost the same as this formula. So this one takes cosine squared and turns it into this. Difference is the sign between them, right? They both turn into cosines. They both double the angles, yes? Mm-hmm. So the way that I remember it is that when I'm doing sine squared and I want to do the power reducing on it, sine means subtract. I have to remember this format, but I have, sine means subtract. Cosine, well, it's not sine, so it must be add. However you want to memorize it, you can memorize it, but those are our two formulas, the power reducing formulas. Very, very valuable formulas. Now, let's tweak these formulas just a little bit to get to the half angle. Okay, the half angle, to get to those, all we do is take the square root on both sides. So if I take the square root on the left side, I get just sine theta. If I take the square root on the right side, I have to do plus or minus, don't I? Because I'm taking the square root. Square root of 1 minus cosine 2 theta all over 2. And this one would become what? So that's this one. What does this one become? Cosine theta is plus or minus, right? Square root 1 plus cosine 2 theta over 2. This is not the way it's going to appear in the book, though. If you look up the half angle formula right now, this is not the way it's going to look. And the reason why is because, look, in the formula, doesn't it say half angle? Doesn't that mean like take an angle and half of it? Yes? Nowhere in here do we see any half angles. We see double the angle, don't we? But we don't see any half angles. So here's what we're going to do a final tweak of that formula. I hope you can follow this. You see an angle here, right? And you see double the angle here? You see an angle here, right? You see double the angle here. You see an angle here, right? Do you see double the angle there? Yeah. Yes? It's the same formula. I'm just changing the variable expression here. The formula has this property, that whatever the angle is here, the angle gets doubled here. So how could I change this one? Theta over 2, and then double that angle in here, and it would just be theta. These are the half angle formulas that appear in your book and in the back of in the back page. Yep. Now here's what upsets me when I look at books and pre-calculus formulas, formula sheets. They rarely have these two, and we use these the most in calculus. They always have these two, but never these two. And most students don't understand that you can get from here to here by squaring both sides and then replacing this with theta and that with 2 theta. And you get back to this formula. Square both sides, replace that with theta, that with 2 theta, and you're back here.
So you just get rid of the divisor and just add 2 to the other side and multiply the other side by 2?
No, I'm not multiplying by 2.
Just putting it in there.
Yeah, look, the formula says sine squared of some junk, right? Some junk here turns into blah, 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 twice the junk, right?
Yeah.
Junk here, twice the junk here. It doesn't matter what I put here. I could put, let's say I put 3x here. Then this formula, this would have to be what? 6x, right? So if I choose to put half of theta here, then that's just going to be twice of half, right? Twice that, 2 times that is just theta. That make more sense?
Yes.
Okay.
I was just asking about the substituting of the numbers. How they change. But I understand what you're saying.
You understand?
Yes.
Okay.
I've been practicing this one a little bit.
Okay. All right, let's try something with this. Okay, here we go. Let's do let's say we have cosine of theta equals -1/7 and theta is in quadrant 2. So I'm giving that to you. All right? Find sine 2 theta. Find cosine 2 theta. Find sine of theta over 2. And find cosine of theta over 2. Parts A and parts B, we have already done, right? Problems like this. Part C and part D, I have not done, but I just provided you the formulas, didn't I? Now I'll put the formulas back up on the board. I'd like for you to work on these together for the next couple of minutes. See how far you can get on these, all right?